I think you'd say like chapter 3, section 3, scene 2. And action. See, we could improve on this. In the Solve It, you use parallel lines to find congruent and supplementary relationships. Caught myself squinting there a little. Of special angle pairs. Remember those alternate interior, alternate exterior, corresponding, all those different angle pairs. In this lesson, you will do the converse. You will use the congruent and supplementary relationships of the special angle pairs to prove that lines are parallel. So in a sense, we're working in the opposite direction. Prior to this, we were told that lines were parallel and that there was a transversal intersecting them. And then we could determine things about angle relationships, whether they were supplementary or congruent. In this case, we're going to be told information about angles. And based on what we know about special angle pairs, we can then state whether or not the particular lines are parallel. So first theorem here in this lesson, theorem 3-4, the converse of the corresponding angles theorem. Make sure you add this to your notes. It says if two lines and a transversal form corresponding angles that are congruent, then the lines are parallel. An example here. Imagine we didn't have this information. Let me go back a touch. There we go. So we didn't know that these two were parallel yet. But if we're told that angle 2 and angle 6 are congruent, like we are told here, then we know that lines L and M are parallel. So again, just working in the opposite direction from the last lesson. Problem number 1, and we'll have at least one got it question after. Which lines are parallel if angle 1 is congruent to angle 2? Justify your answer. So angle 1, we're told, is congruent to angle 2. So I made marks to indicate that to us, and then we're to justify our answer. So we need to figure out, we have 4 lines here. Because we're given angles 1 and angle 2, we're going to use that information to help us determine which are going to be our parallel lines and which will be our transversal. Something to note, as I change my ink color here, is that angle 1 is part of this group of 4 angles, and angle 2 is part of this group of 4 angles. Remember, the transversal creates 8 different angles. Here are 8 different angles that are being created not by line B, not by line A. Some of them are. Some are created by line B, some are created by line A. None of those 8 are created by line L, but line M contributes to all 8 of those angles. So M is our transversal, meaning that lines A and B will be parallel. And we can state that by the converse of the corresponding angles theorem. Which lines are parallel if angle 6 is congruent to angle 7? And justify your answer.